2002 National Electrical Code prohibits the installation of lighting and data conductors within the same raceway or power pole. This separation is mandated to mitigate potential interference and ensure the integrity of both power and data transmission. The code recognizes the different characteristics and vulnerabilities of power and data circuits, preventing the mixing of these systems within shared enclosures. This separation minimizes the risk of electrical noise or electromagnetic interference from affecting the sensitive data signals, while also reducing the likelihood of damage to data cables from the higher voltage power conductors. However, the code permits the combination of power and data conductors within specific types of approved cables. These cables are engineered with internal shielding and separation mechanisms to isolate the power and data conductors, ensuring that the risk of interference or damage is negligible. These approved cables typically include features such as twisted pair data conductors to reduce electromagnetic interference and grounded shields to further isolate the data signals from the power conductors. The cable's overall construction must meet stringent safety standards and undergo rigorous testing to ensure that it can withstand the electrical stresses and environmental conditions expected in the installation environment. The use of approved cables offers a convenient and space-saving solution for running both power and data circuits to various devices and equipment. Firstly, it's important to identify and understand the specific sections of the 2002 National Electrical Code that address the separation requirements for power and data conductors. These sections detail the specific circumstances under which conductors must be kept separate and the allowable exceptions for approved cables. Secondly, ensure that any cable used for combining power and data conductors is explicitly listed and labeled for that purpose by a nationally recognized testing laboratory, such as Underwriters Laboratories or Electrical Testing Laboratories. The listing indicates that the cable has been tested and certified to meet the safety and performance requirements for combined power and data applications. Thirdly, when installing approved cables that combine power and data conductors, adhere to the manufacturer's instructions and any applicable local electrical codes. Correct installation practices are crucial to maintaining the cable's integrity and preventing potential hazards. Fourthly, consider the specific environmental conditions of the installation location when selecting approved cables. Some cables are designed for indoor use only, while others are suitable for outdoor or harsh environments. Ensure that the cable's construction and materials are compatible with the expected temperature, humidity, and exposure to chemicals or other contaminants. Fifthly, when routing cables that combine power and data conductors, maintain proper separation from other electrical and communication cables to minimize the risk of interference. Avoid running these cables parallel to high-voltage power lines or other sources of electromagnetic interference. Sixthly, ensure that all connections and terminations of the approved cables are made in accordance with the manufacturer's instructions and using approved connectors and accessories. Proper termination techniques are essential for maintaining the electrical and mechanical integrity of the cable and preventing signal degradation. Seventhly, periodically inspect the installed cables for any signs of damage or deterioration. Look for cuts, abrasions, or discoloration of the cable jacket, as well as any loose or corroded connections. Replace any damaged cables promptly to prevent potential hazards. Eighthly, understand the grounding requirements for the approved cables and ensure that the grounding system is properly installed and maintained. A properly grounded cable shield can significantly reduce the risk of electromagnetic interference and improve the overall performance of the data circuits. Ninthly, when making any modifications or repairs to the electrical system, always energize the affected circuits and follow safe electrical work practices. Work with qualified electricians and ensure that all work is performed in accordance with the National Electrical Code and local regulations. Tenthly, the allowance for combining power and data in specific cables doesn't negate the need to carefully assess the overall design and layout of the electrical and communication systems. Careful planning can help minimize the potential for interference and ensure that both power and data circuits operate reliably and safely. In addition to the general requirements for separating power and data conductors, the National Electrical Code also addresses specific applications and installations where these requirements may be modified or waived. For example, certain types of equipment, such as lighting fixtures with integrated data controls, may be permitted to combine power and data conductors within the fixture enclosure. However, these applications typically require specific listing and labeling to ensure that they meet the applicable safety standards. Furthermore, the NEC provides guidelines for the use of cable trays and raceways to support and protect electrical and communication cables. These guidelines specify the allowable fill ratios for cable trays and raceways, as well as the minimum separation distances between different types of cables. When installing cables in cable trays or raceways, it's important to follow these guidelines to prevent overcrowding and ensure adequate ventilation. Overcrowding can lead to overheating and damage to the cables, while inadequate ventilation can exacerbate these problems. The NEC also addresses the use of surge protective devices to protect electrical and communication equipment from voltage surges caused by lightning strikes or other transient events. Surge protective devices are designed to divert excess voltage away from sensitive equipment, preventing damage and ensuring continued operation. When selecting surge protective devices, it's important to choose devices that are specifically rated for the type of equipment being protected and that meet the applicable UL standards. In addition to the technical requirements of the NEC, it's also important to consider the administrative requirements for electrical installations. These requirements typically include obtaining the necessary permits, complying with local building codes, and undergoing inspections by qualified electrical inspectors. Failure to comply with these requirements can result in fines, delays, and even the shutdown of the installation. The National Electrical Code is a comprehensive document that covers a wide range of electrical safety topics. It's essential for electricians, engineers, and other electrical professionals to have a thorough understanding of the NEC and to stay up to date on the latest revisions and interpretations. The NEC is updated every 3 years to reflect changes in technology and industry best practices. The National Fire Protection Association, which publishes the NEC, also offers a variety of training and educational resources to help electrical professionals stay informed about the code. In addition to the NEC, there are also a number of other standards and guidelines that may be relevant to electrical installations. These standards may cover topics such as grounding and bonding, wiring methods, and equipment installation. It's important to be familiar with these standards and to follow them when applicable. The goal of the National Electrical Code is to ensure the safety of people and property from the hazards of electricity. By following the requirements of the NEC and other applicable standards, electrical professionals can help to create safe and reliable electrical installations. The specific allowance for combining power and data conductors in approved cables is often found in Chapter 7 or 8 of the NEC, which deals with special systems and low-voltage systems, respectively. The exact section number may vary depending on the edition of the NEC, but the general principle remains consistent to ensure adequate isolation and safety. When selecting and installing these approved cables, it's critical to pay attention to the cable's markings and specifications. The markings will indicate the cable's voltage rating, conductor size, insulation type, and any special approvals or certifications. The specifications will provide detailed information about the cable's construction, performance characteristics, and installation requirements. It is also important to consult with the cable manufacturer or a qualified electrical engineer to ensure that the selected cable is suitable for the intended application. Factors to consider include the ambient temperature, the presence of moisture or chemicals, and the potential for mechanical stress or damage. When installing cables and raceways, it's essential to follow the NEC requirements for fill ratios and bending radii. Overfilling a raceway can make it difficult to pull cables and can also damage the cable's insulation. Exceeding the minimum bending radius can also damage the cables and reduce their lifespan. The NEC also provides requirements for supporting and securing cables to prevent them from sagging or becoming damaged. These requirements vary depending on the type of cable, the distance between supports, and the environmental conditions. When installing cables in hazardous locations, such as areas with flammable gases or dusts, it's essential to follow the NEC requirements for explosion-proof wiring methods and equipment. These requirements are designed to prevent electrical sparks or arcs from igniting the hazardous atmosphere. In addition to the NEC, other codes and standards may also apply to electrical installations. These codes and standards may be issued by local, state, or federal agencies, as well as by industry organizations. It's important to be aware of all applicable codes and standards and to follow them when designing and installing electrical systems. Proper planning and design are essential for ensuring the safety and reliability of electrical installations. This includes selecting the appropriate wiring methods and equipment, providing adequate overcurrent protection, and ensuring proper grounding and bonding. It also includes considering the potential for future expansion and changes to the electrical system. Regular inspection and maintenance are also critical for maintaining the safety and reliability of electrical installations. This includes checking for damaged or deteriorated wiring, loose connections, and other potential hazards. It also includes testing the operation of overcurrent protective devices and other safety equipment. By following these guidelines, electrical professionals can help to ensure that electrical systems are installed and maintained in a safe and reliable manner. The information presented here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician or electrical engineer before making any electrical installations or modifications. Failure to follow proper electrical safety practices can result in serious injury or death. In summary, the 2002 National Electrical Code generally prohibits running lighting and data conductors in the same raceway or power pole to prevent interference and ensure safety. Approved cables designed for combined power and data are an exception, offering shielded and separated conductors. Always consult the NEC and local codes. Use listed cables, follow manufacturer instructions, consider environmental conditions, maintain separation, ensure proper connections, inspect regularly, and follow safe work practices. The goal is to provide safe and reliable electrical and communication systems.